Hello, people. Welcome to Health Tech Academy. So, today I'm going to start a short series on structured query language, which is also called SQL. And this is going to be part of a bigger series, which is data engineering. So, where we are going to learn about data warehouses, using Python to extract and transform the data, process the data. So in this series, we are going to learn about basics of SQL. Also, we are going to learn about some advanced concepts. So let's get started. So guys, what is SQL? SQL is structured query language. So all of you must have heard about databases, okay? Databases is like core of all the softwares. So may it be Facebook or may it be Instagram or may it be any application that you use in your day-to-day life, or may it be any healthcare application that is used in hospitals or clinics. So database is where all the data is stored. Okay, so for example, let's take a hospital system. So when a patient visits a doctor, and if he's not registered in the system, the doctor will open his software and ask him for his basic information like his first name, last name, date of birth, and maybe his some medical conditions and everything, and he will save it in the system. So what happens when when any information is saved from the software, from the user interface that you see, it is stored in a database in the backend. Okay, and to interact with that database, so basically to ask that database for some data or to manipulate some data, to create a new data, there is a language that is used, and that language is called SQL, structured query language. Now guys, before I dive deep into this topic, let me tell you one thing. So think about this. The world is moving towards AI. Okay, now no matter, AI can write code for you, AI can do a lot of tasks for you. However, one thing that remains the core of AI, and which is important even for, even to make LLMs, large language models, is data. So in today's world, data is nothing less than oil. So we say data is oil because data is very important, and hence if you know how to interact with the data, if you know how to manipulate data, how to play with data, you are invincible. And that's the reason I have started this series, so that all you guys there, all the students or all the professionals, uh, you would learn how to retrieve data from the databases. You would be able to do analytics using that database, using the data in the database. So let's get started, guys. So I've already told you what SQL is. Now there's a software, okay, which uh, manages the database, and that is called Relational Database Management System, RDMS. You must have heard this jargon a lot of times, but it is nothing but it's a simple software which interacts with the database and which talks to the database basically. So some of the examples of RDBMS is MySQL, PostgreSQL, or Oracle, etc. Uh, okay, very important concept. So you must have heard there are two types of databases. One is relational database and other is non-relational database. And when to choose SQL over NoSQL. Okay, so let me first explain you in very basics what a relational database is and what a non-relational database is. Okay, so A relational database is basically where all your data is stored in form of tables. Okay, so okay, we are going to look at a live database, and you would see what I mean when I say that the data is stored in form of tables. Uh, but yes, and in non-relational databases, the data is basically stored in form of documents or JSON format. Okay, I will I will explain you in between of this series what exactly relational versus non-relational is, because right now it will confuse you. Okay, so just hold on, and when the time is right, I will tell you what exactly I will show you how a relational database looks and how a non-relational database looks. Okay, so moving ahead, so there are some basics, basic SQL queries, and they are like select queries. So this is basically used to select or to retrieve the data, to see the data in the database tables. Okay, now let's actually go ahead and see what I mean by this. Okay, so let's move to our MySQL workbench. So before I start with actually querying the database and creating a database, let me first show you how to install MySQL. Alright guys, so to download MySQL, you just go to Google and type in download MySQL, and from here you will go to the official website of MySQL. Click on MySQL downloads and scroll down, and you will see MySQL community downloads here. Just click on it and select MySQL installer for Windows if you're using Windows. Here select the version and the operating system and click on download. Okay, once you click on download, your download is going to start. Say no thanks, just start my download. Okay, from here, once your download is started, then just go ahead, double click on the installer, and your installation will start. Just follow the instruction as you go. So I'm not going to spend time on installing this, as I have already installed it. So let's move back to MySQL Workbench. So once you have downloaded and installed your MySQL Workbench, this is how the MySQL Workbench screen looks. Okay. Uh, so from here, this is the schemas section here. Okay. Here it will show you all the database objects, and by that I mean that all your databases, like in my case it is showing clinical data warehouse, measures configuration, measures mart. These are the databases, and under this, if you click here, it will show you all the tables, and if any views or any stored procedures, any functions that you have created. Okay, and here in the administration section, you would see all the things that are required for administration purpose, like your server status and your to create your users and privileges, exporting the data. Okay, so all those administration tasks can be done from here. So for this video, we are going to mainly focus uh, on the schemas. Okay, so basically on this section. Okay, so let's go ahead. So now I already have my database created, and I have some tables inside it. Okay, so basically, if I just click on this icon here, SQL, it will just open a query editor window where I can go and just type a query to retrieve some data from the database. So let's try one very basic query. So this is the data warehouse. Okay, and these are my tables. So let's look at the patients table. So what I'm going to do is I'll just do select star from patients. Okay, and instead of don't limit, it's always good when you're playing around, just limit your results to something, like 10 or something, so that uh, if your table is very big and it has millions of records, then it's going to take time and it's going to put load on the database. So it's always good when you're playing around, just use limit to 10 rows, or you can also just do limit 10 here. Okay, and that is also going to work. So, and when you want to execute the query, this is the button, okay, where to execute the query. So alternatively, you can also press Control Enter to execute the query, and that's also fine. So if you see, there's already a table here which is called patients, and this table has key like ID, patient ethnicity, all the columns. These are called columns. Okay, ID, patient ethnicity, client ID. These are called columns, and this is a row. Okay, let me show you how we can create a table. Okay, because that's a very basic. So when you don't have anything, you first need to create a database. Okay, so to create a database, the command is create database, and then you can give any database name. So we already have clinical data warehouse, so let me give it clinical data warehouse new. Okay, and the semicolon is to terminate this query. So basically it shows that this is one script. Okay, so once I click here, see, it says create database clinical data warehouse new, and it says one row affected. All right, so now if I go here and if I say refresh all, uh okay, you see I have a new schema now, clinical data warehouse new. Okay, and there's nothing inside it, it's completely empty because we just created it. Okay, now after this we want to create patients table. Okay, so suppose I want to create patients table inside clinical data warehouse new. Okay, so I would say create table, and then the name of the table. uh, So I can put a fully qualified name. So right now I have selected clinical data warehouse schema. See, it says it shows in the in bold. So that means I have selected this. But I can either just double click on this and select our new database that we have created and say create table patients. Okay, or I can give it a fully qualified name saying that create table, and then the database name, which is clinical data warehouse underscore new, and then say dot patients. That means this not dot notation means that uh, create it inside clinical data warehouse new database. Okay, and dot patients, and after this open bracket, and you give the name of the column first that you want to create. So first column I want to create is ID, uh, and the data type of the column. So I would say big int, and if there is any constraint on the column, then that. Okay, so constraints are like if this is a primary key, so I would say primary key. Okay, like this, and then second column maybe first name, then again the data type of that column. So first name we want varchar. Okay, so varchar is a data type where you can store alphanumerical values, and in varchar then you have to mention uh, the number of characters that this column should allow, the max number of characters that this column should allow. So first name, let's take it 100. Okay, and then comma, and then let's say last name, last underscore name, and again the data type, so last name again varchar, and we will say 100. Okay, and this is how we create a table basically. So just for example, you can I'm going to create this small table. Okay, we got an error saying that unknown database clinical date warehouse underscore new. So obviously I have spelled this incorrectly. So it's very important that all your actions and all the responses to that action, you can see it in this output section. Okay, action output. So in this case, I tried creating a table, but it gave me an error and it says unknown database. So let me see what I have done. Okay, so basically there's a spelling mistake, clinical data warehouse. Okay, now let's try it. Now see, our table has been created. Okay, and to see that table, we can just do select star from, again, clinical data warehouse new dot patients here. So we don't have anything in our patients table. Okay. Uh, Now this was just for an example that I showed you how to create a table. But let's look at a real table. And what I mean by real table is that this clinical data warehouse schema or database that I've created, this is an actual test database of a production grade system that I have created. So let me show you the actual query that I have used to create patients table in this. So if you want to see uh, a create statement of any table, you can just right click on that table. Okay, and you can do send to SQL editor, and if you want to see insert statement, you can see insert. If you want to see update statement, you can see update. If you want to see delete, you can say delete. Okay, but right now we want to see what is the actual query or actual SQL script that I have used to create this patients table. So let's look at it. Okay, now if you see it's a very big query. Okay, and it is similar, the structure is similar. So if you see here, create table patients. Okay, open bracket, and then you mention inside the open and close bracket, you mention all the columns. Okay, or the constraints. So by column, what I mean is id is a column. It's of type, data type is big int. Okay, and it is not null. So this id will not allow any null values. Okay, and it says auto increment. Okay, so auto increment means that if a value is not specified when inserting data in this table, if we'll go there as well, so you'll understand it better, but just make a note of this right now. So when inserting data in this table, I have to give all the values for this column. What is going to be patient id, patient ethnicity key, client id, last name, first name, etc. Okay, and if I don't provide a value for id, it will automatically take the max value in the id column in that table, add 1 to it, or yeah, and just auto increment it. Okay, so that is called auto increment. So yeah, that's the syntax to create any table that you want. Okay, now some important things that I want you to note here is uh, okay, just look at this. Now you can mention primary key directly here as well near the id. Okay, that's also fine. Like you can say, and you saw it in the example that I provided you. So you can say like this, primary key, or once you have mentioned all the columns that you want to create, then you can mention all the constraints. Okay, and the constraint, so here we see a constraint called as primary key. Okay, so we will see what exactly a primary key is. Okay, uh, it is basically a unique identifier for any record in that table. So primary key is internally taken care of, okay, and it is always unique. You cannot have a duplicate value in primary key, or you cannot have so if you have mentioned not null here, you cannot have null values in the primary key, okay. Unique key means that now we have created a unique key here called as client ID, which is a composite unique key. Composite unique key means that a combination of client ID, master patient ID, and effective start date cannot repeat or cannot be duplicate. Okay. Uh, so as we go ahead, I will explain you again with an example what a primary key or unique key is. Okay. And then here we have created indexes on the table. So guys, it's too early to learn about indexes. So I'm going to hold on to this topic indexes. Okay. Uh, and we are going to move forward. So hope you all understand what or how to create a table. Okay. Anyways, if you want to drop a table, like delete a table, this is the way to do it. Okay, I don't see table here. Now I do. I have refresh. So patients table. You can just right click or say drop, or you can just say here drop table and the table name. So you can also double click like this, and the it will get pasted here. Okay, so you can just say drop table. Okay, and we have dropped the table successfully. All right, guys, so now let's see how to insert a value in any table. So as an example, we will take our patients table. I'll just do select star from clinical data warehouse dot, and then I get all the table names here. Okay, so this is autocomplete feature of MySQL Workbench, and I'm just going to select patients. And okay, so in MySQL, what you can do is you can also insert the values directly from here, but we don't want to do that. We are learning SQL, so we are going to learn the syntax, and we are going to insert the data via a SQL script, okay, because that's what you guys will do when you're actually working or making a software. So let's see what is the syntax of inserting uh, inserting data into table. Okay, so what we do is just insert into and the table name. So in this case, I'm just going to copy paste it, insert into clinical data warehouse dot patients, open bracket, and I'm going to mention the name of the columns here. So I'm going to just have a look at what columns I have. So ID column is a primary key, this one, and I don't want to specify a value because this is an auto increment column. So if you see this is 22, automatically this will be 23, the next record that I insert. So I'm just going to take patient ID. Okay, so you have to mention the name of the columns that you want to insert the data into. So patient ID, comma, so we'll do client ID, comma, we will not insert any data into master patient ID, just like that. No reason, no specific reason for that. And we'll insert into last name and first name. Okay, and maybe street address line 1. Okay, then I close this. Okay, we are only going to insert the data into these columns: patient ID, client ID, last name, first name, street address, line 1. Then I mention here values. Okay, and then I open a bracket, start putting values. So for patient underscore ID, I want 1013. Okay, for the columns which are of data type integer, so big int, you can directly put the values like this 1013, okay, without any quotes. So for my client ID, so patient ID 1013, my client ID, let's put 1 for now, and the last name of the patient. So now here, because this is varchar, I'll have to put it in single quotes. So last name, I'll put it my name, Chaudhari, comma, and first name, Jay, comma, street address line 1. So again, in wrapped into single quotes, because this is varchar data type, like a string alphanumeric. So first line of address, I'll do uh, 888 Ohm Street. Okay, and close the brackets here. And it's good practice to terminate the script with a semicolon. Okay, so let's execute the script and see what happens. Okay, so it says here one row affected. Okay, so let's again look at our table, select star from clinical data warehouse dot patients. So if you're executing, like if you have multiple scripts, SQL scripts in one SQL editor window, and if you want to execute a specific script, then you'll have to select that script like this, and press execute button. Okay, now let's look at the record here. So we have our record created 1013. See how the primary key auto incremented from. So I did not give a value, but it auto incremented. Remember, because when creating a table, we had the constraint for the ID column saying that it's primary key and auto increment, and that's the reason it's being auto incremented. Patient ID 1013, my last name, first name, and 888 Ohm Street. Okay, so we have our first record created. Okay, now we we have seen how to create a table, how to drop a table. Now let's see how to delete a specific record from the table. So for that, you say delete from the name of the table. So we will just copy this and paste it here. And remember, guys, never run a delete statement without a condition, else the entire data in that table is going to be deleted. Okay, and it's very, very risky. So when you guys are at your job, okay, you're working, just be very, very careful with this delete and update statements. Okay, so now what we'll do is we'll add a condition here. So I'm telling the SQL engine that delete from this table. Okay, but what? So I say where, we can say ID equals 23, because if our patient ID equals 1013. Okay, so to delete a row, always select a condition which is unique, like there is no other row which has ID of 23 or patient ID of 1013. Okay, so if I say where ID equals 23, and if I run this query, let's see what happens. So you see the output here, it says one rows affected. Okay, so let's query the table and see what happened. So I'll do select star from clinical data warehouse dot patients. Okay. And you see our record is not there. So our record has successfully been deleted, guys. Okay. Okay. Let's enter that record again. Okay. Now we have seen how to delete a record. Now let's see how to update a record. So in some cases, we might need to update a record. So let's see the syntax to execute an update query or to write an update query. So you start with update and you say the table name. So we want to update some data in the patients table, but what? Okay. So what do you want to change here? Let's say we have this patient ID 24. Now just pay attention, guys. All right, guys, just one thing to notice here. You see how when I created a record, same record with patient ID 1013, but now the ID is 24. So this is one of the features of the primary key, that it it remembers the last value that it had assigned to this column. So even if the 23 value is now deleted from the table, but it is still in the metadata. So what I mean by metadata is that the system still remembers that uh, the last value stored here was 23, and now it has to assign a value 24 and not 23 to this column. Anyways, so now we were looking at how to update something. Okay, so I can update one row. So I can just update this row. I can say update clinical data warehouse dot patients, and then you use a keyword set and then the column name. So maybe my first name was misspelled when I was registered in the system. So now I want to change it. So I say set first underscore name equals, it's not JAY, it's JAI. Okay. Now remember, guys, if I run this query without a where condition, all the patients first name will get set to JAI. Okay, because there is no where condition. So what it does is it updates the entire table. So again, you have to be very careful when updating data in the tables. Okay, so now I give it a where condition. I say where ID. Okay, always a good practice to use a column in the where condition which has unique values, and always it is going to be your primary key. Okay, if it exists in the table, that's so that it's a good practice. I can do anything. I can do where ID equals 24. Okay, I can run this and this will get updated to JAI, or I can do where patient underscore ID equals 1013. This will also work, but let's first try it with ID equals 24. Okay, so I'm going to run this query. So as soon as I run this query, just check here. It says one rows affected, rows matched one. Okay, so with where condition here, one row was matched. It changed one row. Okay, and zero warnings. So now let's look at our table again. Okay, now I have patient ID 24 and the name has been changed to JAI. My first name changed to JAI instead of JAY. Now let's change it again back to JAY, and this time let's use patient ID. Okay, where patient underscore ID equals 1013, and you will see the same result because there's only one row which matches this condition, where patient ID equals 1013, which is this row. Okay, so I'm just showing you how you can use any of the columns in your where condition, provided you are sure that you're going to change the records that you intend to change. Okay, so it's always good to use keys like primary keys like id and then patient id in case of updating or deleting the data. So let's run this now. Okay, here again you see one row affected, one changed. Let's look at the data. Okay, so id 24, patient id 1013, name changed back to JAY. uh, Another easy way, you just want to update, you can just do it from this graphical user interface. So you can just go in this table and you can just do J, instead of JY I just do JAI and do apply. Okay, it says review the SQL script to be applied, so it gives me the same SQL script that I have used. Okay, it says update clinical data warehouse dot patient set first name equals J, where id is equal to 24. Okay, fine, I'm good with that. So once I click on apply, okay, SQL script was successfully applied to the database. Finish, and if you see, my name has been changed back to JAI. So again, when I run, if I run this select star from clinical data warehouse dot patients and go back to my record, which is 24, see, it got changed back to JAI. Okay, now you can also not just update the columns which has values, but I can also update the columns, like suppose I want to fill in my street address line 2 and my record already exists. So I'll just say set this column. So I'm just going to copy the field name, paste it here. Okay, set street address line 2 equals 233 Avenue. Okay, where patient ID is equal to 1013. Run this query. One row affected. Let's see. See, ID 24, patient ID 1013, and now I have second line of address 233 Avenue. Okay, so I hope this is clear. So now till now we have seen basic select query, how to create a table, how to delete a table, how to insert data into table, and how to update the data in a table. Okay, now let's move to some no, let's learn about some different select queries. So when I do select star from patients, it selects all the data, all the rows and all the columns from that table. But what if I don't want to select all the data fields, right? So I can do this also. So I just want to select specific data fields or specific columns from a table. So I will just do select last name, comma, first name, comma, street address line 1, comma, let's see what other useful columns or we have. So city, comma, state code, comma, zip code, then if you don't want to type in all these column names, you can just simply click on this column, copy and paste it. Date of birth. Okay, now I just want to select this specific column, so I can just simply do select all the list of the columns, okay, which separated by comma and from patients. Now see, now you only get the columns that you want to see. Okay, now let's move to how we can conditionally filter this. Okay, so I don't want to see all the patient's information. I only want to see the patients where date of birth is greater than, so I have this patient who's born in 1965, 68. So I only want patients whose date of birth is greater than or equal to 1980. Okay, so I can just do where condition like this, where date of birth greater than equal to and then single quote I can, and then look at the format of date here. So it is year, so I'll do 1980 dash month 01 dash 01. So I want all the patients who are born on 1980 Jan 1st or after that. Okay, so let's run this query. Now see, now you have received all the patients where the date of birth is after 1980. Okay, so that's how you use the where condition to filter. Now you can use multiple where conditions like date of birth equals this and the patients who live in California. So I'll just say and state code equals CA. Let's run this. Now see, I only got one record where the patient's date of birth. So when you do and, it will return that record which matches both the conditions. But if you do or, then it will return all the patients where date of birth is greater than this, or so it will basically also check for the state code CA and it will return that record as well. So see, so when you change it from and to or operator, how now it shows the patient which has a state code of California, or those patients which are born after 1980. Okay, so let me show you. So this patient, let's take a patient who's born before 1980. So let's take this patient who's born in 1972, okay, June 12th, and his state code is GA. So I'll just put GA here. So if you see, what will happen is it will return all the patients where date of birth is greater than or equal to, after 1980, and it will return this patient as well this time because we have said or condition and state code is equal to GA. So let's look at it. See. So this is how you club the conditions with and or operator. So now vice versa, if you want to see the patients which are born before 1980, so you can do where date of birth is less than equal to 1980. Okay, and let's run this query. So now we get all the patients which are born before 1980. Okay, so we have seen how to use equal to operator, less than equal to, greater than equal to. Now let's see how to use not equal to operator. Okay, so not equal to operator is like this, and I want all the patients which are not born on 1980 April 15th. So basically we are excluding this patient John Doe because here the patient's date of birth is 1980 April 15th, and I'm giving a where condition in my where clause where date of birth is not equal to April 15, 1980. So let's see and see. Now John Doe is not in our list. Now similarly there is another operator which is called between. So you can say where date of birth between, let's say I want patients which are born between 1980 and 1995. Okay, so I will say where date of birth between 1980 Jan 1st, and then I use and keyword. Okay, and I say 1995-01-01. So it will return only patients which are born between these dates. Okay, let's see. Here you go. Okay, so you can use between keywords, keyword, and you can just specify the lower range and the higher range, and use and keyword between, between this higher and lower range. Now the same query can be written in a different way as well, where I can say where date of birth is greater than equal to 1980 and date of birth is less than equal to 1980, and the result should be the same. See, because it does the same thing as between operator. Okay, so basically between is a shortcut, and it's a efficient way of just getting the patients or getting the data between that range. Okay, I can also do where, let's say, id. Okay, id between, now id is a primary key, so I can say id between 1 and 10. Okay, let's add id column also in our select clause so that we see what if our results are correct. Okay, so I mentioned where id between 1 and 10, so now we get this result where our id column less than 10 or equal to 10. Okay, or greater than 1 and equal to 1. Okay, so this is how you use between operator. Now there is another operator which is like. So I can say where street address line 1, and I can say like. Now like is used for pattern matching. So basically, let's say, what all addresses do I have? Let me just first run my select query, and okay, road, street, lane, street. Okay, all right, great. Okay, I'll just change this. All right, now I want all the addresses that has a street like st in their value. Okay, so I'll use like keyword, and I'll say, so like is used for pattern matching, as I told you. So I would say percent, okay, st. So basically what this means is percent means anything before st. Okay, and this percentage means anything after st is fine, but I want all the street address line 1, all the records which has a value in street address line 1, that value is equal to something st something. Okay, so if I run this, let us see what we get. So okay, I get all the addresses which has st in it. See, st. Okay, in same way I can use it on telephone value as well. So let's see. So where telephone value is the name of the column, but these are just telephone numbers, like, and see here in this case I said percentage st percentage, so wherever st is in between anything, it will return that. But now here what I want to say is 555%. So this means that anything that starts with 555 and then anything, basically this percent sign is for anything. So any value after 555. So if I run this, let's see what we get. See, I got all the telephone numbers that start from 555 and then there's anything after that. Okay. So I can use this like operator and then this percentage sign for pattern matching. It's very powerful. So in this case, if I want to say, where the date of birth is like 1980, so I can just say 1980 where date of birth. Okay, let's see. All right. So that's how you use the like operator. Okay. And then the last one remaining is the in operator. And like you use equal to. So suppose where I say ID, so where I say patient underscore ID equal to, okay. So let me add a patient ID in our select clause. Not necessary, but I want to see the values of patient IDs. So let me run this query. So patient ID equals 1001. Okay. And if I run this query, it will return me one row because only one patient has patient ID 1001. But what if I want to compare multiple values? Can I do this? 1001, 1002, 1003? No, I cannot. It's a syntax error. Okay. So in this scenarios, I would use keyword in. So patient ID in, then you can specify multiple values inside a bracket separated with comma. Okay. Now let's see what this returns. See. Okay. So same way, this in operator can be used on any column. So let's use it on last name. Okay. So where last underscore name in, and then remember, whenever I am comparing with varchar, it has to be in single quotes, wrapped into single quotes. So where last name in Doe, comma, Smith, let me see what are the other last names, and Smith, Chaudhary, Chaudhari. Okay, let's run this. Here you go. So it returned, or it fetched all the rows where last name is in Doe, Smith or Chaudhary. So hope this is clear. Here you can also use keyword limit. Okay. So suppose I want to return only two rows matching this criteria. Okay. So if I said limit 2, then what will happen is it will only return this top two rows. Let's check. See. Okay. Though there are other records matching this criteria, but I have specified this limit, it will only return those many number of rows. So if I say limit 10, only 4 rows are matching, so it will return 4. Okay. So that's the use of limit. All right, guys. So let's move forward and look at a keyword called distinct. Okay. So first, let's look at our table, patients. Now here I see that I've created this record just to explain you what is the use of keyword distinct. So we have two records here. This ID 2425, patient ID 1013, 1014, client ID 1, and last name same Chaudhary, first name Jay, same address line 1. Now what I want to do is I want to return records which have unique first name and last name. Okay, so I'll say select distinct first name and last name, okay, from patients. If I just run this query, let's see what I get. Okay, so I get John Doe. Okay, but if you see, it only returned one record for Jay Chaudhary, whereas we had two records for Jay Chaudhary, right? That is because we have used this keyword distinct, and whatever columns we used after distinct, it will return records that has unique values in this column. So that means the combination of first name and last name should be unique. Okay, that is what distinct keywords does. Now look here. Now if I just add a column ID here, okay, after distinct, so what it will do is now it will look at the ID first name and last name combination. So if I run this query, what do you expect? What should happen? Think. Okay, let's run it and see. So if I run select distinct ID first name last name, now see what happens. Now it returned two rows. Why? Because this and this is not distinct. You know, this ID has 24 value and this has 25 value. So for this, it looks at the combined value of all the columns that you used after distinct. Okay, so suppose if I look at all the values from patients table. Okay, now what will happen if instead of ID, if I do patient underscore ID here, will it still return two values for Jay Chaudhary or one? You are right, it will return two values because it has different patient ID. So this combination is not unique. Okay, however, now tell me this, if I remove patient ID from here and I say select distinct first name last name comma street address line 1, now tell me what will happen. Look at this. Will it return two different values, two different records, or one? Absolutely right. Yes, it will return only one record because now after distinct, I'm taking a combination of first name, last name, and address line 1, and all the values for these two records, these three values are same. So it will only return one unique record, Jay Chaudhary. Okay. I can also filter it by just adding a where condition where. So now tell me, what if I just want to select, I want to get distinct values for first name, last name, street address, line 1 from patients table, but I don't want it to search for all the patients. I only want it to return for ID 2425. So what will I do? Right, I will add a condition where ID, and what is the keyword operator I'm going to use? Exactly, in, because we are comparing multiple values. So 24, 25. Now tell me what will happen. How many rows in total it will return? Now see, when I was running this, it was returning total. Okay, let me clear this first. So I can just hit clear. Okay. So when I was running this, it was returning 13 rows. Okay. But now if I add a condition where ID in 24, 25, what will happen? Will it return two rows because where ID 24, 25? It should return two rows, but it filters on two rows and then it compares if those two rows have distinct first name, last name, street line 1. So if they do, then it will just return 1. If they don't, it will return 2. Look at this. Okay. Now let's make a little bit of change so that you understand how this works. Okay, so instead of J, now I'll just change it a little bit. I'll just add Y to it. Okay, and do apply. Okay, done. Now my patients table have Chaudhary Jai, same street line address. Now what will this query return? So the filter where ID in 2425, it will first select this two rows, okay, in the memory, and then it will say, okay, I want distinct first name, last name, street address, line 1. And it will go here, see Chaudhary Jai, 888 Om Street, Chaudhary Jay. Oh no, it's not distinct. So now it will return two different rows. Okay. So hope the use of distinct keyword is clear. Okay. Now let's move to group by. All right. So now let's see what group by does. Okay. It is somewhat like distinct. So let's see what it does. So now I will just select first name from patients table. Okay. And I will do group by first name. So basically what it does is it takes all these first names, William, Elizabeth, David, Susan, Robert, okay, Jan, Jay, and it will group it. So it will group it by first name. Okay. So basically what it does is, so this should be grouped into one row. Okay. So let's see. We did not get two rows with value j in it. We only got one because group by just groups it by the column that you mention after group by. Alright guys, so now let's look at another example of group by. Okay, so I'm going to select first name, last name, comma, date of birth. Okay. Now, if you see here, Jay Chaudhary, okay, date of birth 1985, March 18th for one record. And for one person, it is 1985, March 16th. Okay. Now, let's see how group by will work here. Okay. So, if I do group by first name, comma, last name, what do you think? What's going to happen? So, as I told you, what group by does is it will merge the same values. So if I say group by first name, comma last name, then it will look for the same first name. If two records have the same first name, it will group it into one. If it has same last name, then it will group those two records into one record. Okay. But now here I have date of birth also. In the select clause, I have date of birth. Okay. So let's run this query and see what happens. Okay. So as expected, I got this error and I wanted to show you guys something important. Okay. So it says that select list is not in group by clause. Expression 3 of select list is not in group by clause and contains non aggregated columns. Okay. So basically what it simply is saying is that, hey, I am not able to group by the first name, last name and date of birth because all the columns that are there in the select list needs to be in the group by also. Okay. Or there is one more thing, but first let's look at this. So if I do group by first name, last name, date of birth, then that error will go away and it will give me values like this. But let's remove the date of birth from here, from select clause, and let's remove date of birth from the group by clause. Then what will happen? Then as expected, because these two rows will be grouped by first name, last name and become one. So it was returning 14 rows. Now it should return 13 because the last row got grouped into one. Okay. Now let's go back and let's again add the date of birth column here. Okay. Now I want to, the second error that it gave was that either all the columns should be part of group by or they should be part, or of a aggregated function. So what it means is that if these two columns are part of group by, then the one column that is remaining should use an aggregated function. And we will see what an aggregated function is right after this. But for now, I will say that, hey, return me the max date of birth from the two date of births. So we saw that, okay, let's go back. Just remove this max for now. Let's see. Let's first see our record. Okay. So see, it is returning Jay Chaudhary, and one has date of birth 1985 March 18, one has date of birth 1985 March 16. So what I would say is that you group by these two columns, okay, and return me the max of date of birth. So what it will do is, now it is fine because you have used an aggregated function like max, min, okay, sum. Those are aggregated functions. So what it does is it aggregates this date of birth column. Now it aggregates it to max. So it will return first name, last name, and it will return the maximum value of the last column. So let's see. Let's see it in action. So what I think is it will return 1985 March 18th, and it will return only one row with Jay Chaudhary. Because now for the last column date of birth, I've told it that only return the max value. See, so now Jay Chaudhary 1985 March 18. Now in the same way, if I say return min for the date of birth, then it will group by first name, last name, and it will return the min of the two records that it gets. So it is March 16th, I guess. See, March 16th. Okay. So that is how you use group by. Okay. So hope that is clear. Now you can also use a count function here. Okay. So basically what count does is, first let me show you a simple use of count. So instead of star, if I just say select count of star, so what it does is, so suppose it will return the total number of rows in the patients table. Okay. So if I just do select star from patients, it returns me all the values. Okay. But now I just say count of star, which means that it will return this number 14. See, because there are 14 rows. So it's okay. Now how to use count in combination of group by. So count is also a function. So if I say select first name comma last name and count of star from patients and group by first name last name. So what it will do is it will group all the rows, okay, all the records which have the same first name last name, and it will return what is the count of such rows. So see, now John Doe, we only have one John Doe in our system. Let me show you. So select star from patients. See, I only have one John Doe. Okay, there is no other John Doe. Okay, so that's the reason it is saying that even if it group, after grouping by first name, last name, the count is still 1. But if you see Jay Chaudhary, then it says that it has grouped by first name and last name, and the count of such records are 2. So there are 2 people with the same first name, last name. Now, just to show you, okay, let me add one more Jay Chaudhary here. I'll add ID as 1015. Okay, Jay Chaudhary. Let's add the same address. Oh, no address, it's fine. Client ID doesn't have a default value, so I'll need to provide a value. Client ID cannot be null. So I provide a value. Oops. Yeah. Apply, finish, done. Okay. Now if I run this query, now there are 3 rows which has same first name, last name, So this query now should return, look here. So it grouped by first name, last name, and such records are 3. So that is the usage of count. Okay. Now, when you group by, now and if I want to only return such records, suppose in my patients table, I want to see are there any duplicate patient records. Okay. So what I will do is I will write query like this, select first name, last name. Okay. Count of star from patients, group by first name, last name. But if I run this, it will return me all the records, even the ones which are not duplicate, which just have one count. Okay. So in this case, when I use group by, I do not do where count of star is greater than 1. That means 2 or more, 1 or more. Okay. 2 or more. But this will give me a syntax error because this syntax is incorrect. Let me clear this again. Okay. So instead of where, after group by, you use having. So if you say having count of star greater than 1, now it will return those records which are duplicates. Okay. So here it says that, hey, you have 3 records in your patients table which has the same first name, last name. The first name is equal to J and last underscore name is equal to, okay. So this is some real real life use case in healthcare. So okay, I see, oh yeah, I have duplicate records. Okay, so I need to delete 2, so I can just delete 2 out of this 3 records. All right, so that's the use of having, group by, and count, and hope that is clear. Now let's look at order by. Okay, so order by is quite simple. So if I do select star from patients and I want to return these records in order of their first name. So if I do order by first underscore name, okay. So this order by default is ascending when it is integer. When it is varchar, then it orders by like A, B, C, D. So let's see. First Anderson, David, Elizabeth, Emily, J. So A, B, C, D, E, F, G, H, I, J, K, L, M. Okay. So basically this is the use of order by. So order by will just order the records by the column that you mention after order by. You can mention multiple columns. So first I want to order by first name, and I also want to order by last name. So I just do first name, last name here. So what it will do is, now suppose this J Chaudhary, okay, if I order by first name, so first it will order by first name, A, B, C, D, E, F, G, H, I, J. But if there are multiple J's, okay, and one surname is C and others is, suppose, let's see, let's an imaginary surname C, D, and then this is E. Okay, let me update it. Okay, and now if I run this query, what it will do is, when it hits multiple values with the same first name, then it goes to the last name, because I've mentioned that order by first name and then last name. So what it does is, first it orders by first name. Now it has 3 values here, so which one should show first? Then it goes to last name and says, okay, Chaudhary, C first, then D, then E. Okay, like that. So that is the usage of order by. And I hope that is clear, guys. So in similar way, I can order by an integer column as well. So let's order by patient underscore ID. And I think everybody knows what's going to happen here. So it will order by patient ID. So 1001, 1002, so on. Okay. Now I can order by created date. Okay. So some of the records are created on June 22nd. Some are created on July 20th, which is today, then June 22nd. Okay, so let's order by created at. Okay. Now I want to order it in a descending order. So by default, when I say order by created at, it orders it into ascending order. So from earliest to the latest. Okay. So the older date will come first and the newer will come later. But if I say order by created at descending, DESC, then it will be vice versa. Then the new records that are created latest, they will come first and then the older ones. So let's see that in action. See, created at July 20th, 1731. Now all these other records are created at the same time. Okay. So what we can do is we can say, so let me just select first name and last name. First name, comma, created at. Okay. So we see what happens. And I run this query. So same results again. Okay. Now because all these records are the same. Okay. Now let's order it by the first name. Okay. So now let's order it by first name also. So I'll say order by created at descending. Okay. So I want the latest records first, and then those records which are created at the same time. Okay, let me run this again. Okay, so those records which are created at the same time, which is June 22nd, 10/13/44. So I want to be ordered by first name. Now if I run this, now look at this. What it is showing is first is John, Jane, Robert, Emily, okay, David, Susan. Now it should order it by first name also. Okay, June 22nd. So see, now David has come above Elizabeth. Okay, so that is how you use order by, using multiple columns, using single columns, and I hope that is clear. Some of the functions are count we already looked at, sum, and then average, min, and max. So out of this we have already looked at min, max, okay, what it does. We also looked at count. So now let's look at the sum. Now if you want to sum the value in any column, you can use sum function. But let's see what happens if I use sum like that. Okay, so again, sum is an aggregated function. So remember, now if I say sum of patient IDs, okay, patient underscore ID. So what it will do is it will actually sum the values in it, like 1001 plus 1002 plus 1003, and it will return the total sum. So let's run this query. Let me delete this. Select sum of patient IDs from patients. See, 151120. So if you actually sum this, it will come to that value. Okay. Now let's look at client ID. Suppose how many rows we have in the patients table? 15 rows. So all the client IDs are 1. Okay. This is not a good example, but I'm just showing you how the sum works. So if I, instead of patient ID, if I put client ID, it will sum all this 1 plus 1 plus 1 plus 1 plus 1, and it will return 15. Imagine sum function can be used for somewhere where we have to sum the value, maybe like in salary. If I want to know what is the sum of the salaries that I'm paying to my employees, then in the employee table I can just apply the sum column to the salary. So just imagine like this patient ID is the salary column. Okay, so if I say sum of patient underscore ID, okay, Now we saw this result already is some 15,000 something. Okay. However, now let me just think, what if I do sum of patient ID, comma, uh, comma first name? What will happen? What do you think will happen? This is an aggregated function. It will throw an error. See, again it is saying in aggregated query without group by, expression number 2 of select list contains non-aggregated columns. So either this has to be aggregated, okay, so, or it has to be in group by clause. So if I put this in group by first name, now what will happen? Now what it will do is it will first group by first name, and then it will take sum of each patient ID. So it will return multiple values. Only it will sum it for the last, for the record which is Jay Chaudhary. So those 3 records have been summed up, and their patient ID values coming as 3042, and the first name, because I've grouped by it, so that is returning as this. So I hope the sum function is clear. In same way, I can use average as well. Okay, so let me get rid of this first name and group by, and now let's only use the average function. Now 1008 is the average of all the patient IDs. So it will sum all the patient IDs and divided by 15 rows. So that is average. So yeah, same, these are mathematical functions. So I hope that is clear, guys. So let's move to a very important concept in SQL. So till now we have touched basics, very basics of SQL, how to retrieve the data from tables, how to order it, how to group it, how to use functions like count, sum, average, min, max, how to create a table, how to create a database, how to insert the data into database, how to update the data in the tables. Now we are going to move to joins, and joins is like one of the most important concepts in SQL. The reason being because in real life, in real world scenarios, like when you're actually working somewhere in some software company, you need to know joins. If you want to manage data, you want to fetch data, you need to know joins very well. Alright guys, so now let's look at some advanced concepts like joins. Okay, so as I told you before, joins is a core concept, and it's very, very important for you guys to know, so that you can perform well at your job. Okay, so let's understand what joins are. Okay, so joins are basically used to join 2 or more different tables to retrieve the data. Okay, so we will see an example, or not an example, we are going to have an extensive session on joins. Okay, so I'll actually show you how joins work in real life. Okay, but let's understand some basics about the joins before we dive in deeper. So some of the very basic joins are inner join, left join, right join, full outer join. Okay, so uh, let's skip over to the practicals actually, because that would make more sense rather than teaching you theory, because I believe that when you see something, that makes more sense, and we have a good data set. Okay, this is like all the patient's data, and I'll be able to explain better by showing you the examples. Okay, now let's get rid of all this. Okay, so First we'll look at our patients table. Okay, so let's say select star from patients. Okay, now guys, you see that our patients table has this primary key. Okay, uh, and it has this patient ID. Okay, now do you see this allergies table? So let's look at this allergies table first, what it has. Okay, okay, so basically what our allergies table has is a linkage between the patients table and the allergies table, which is patient ID. So you see the patient ID is present in the patients table as well. It is present in the allergies table as well. Okay, and the main data that is present in the allergies table is actually the kind of allergy that patient has. Okay, so suppose drug allergy, allergic to penicillin. Food allergy, this patient is allergic to peanuts. Okay, environmental allergy, this patient is allergic to pollen. Okay, food allergy, this patient is allergic to shellfish. Okay, and then what happens due to this allergy? What is the allergic reaction? So this patient gets swelling and nausea. This patient starts sneezing and congestion, with the pollen allergy. So basically this is some real world data. Okay, this table shows that, hey, this patient ID 1001 has this allergy. Okay, and this patient ID has this allergy. Now guys, what is a common data point between the patients table and the allergies table? That is our patient ID. Okay, so basically now if I want to know which patient has which allergy, how would I get that data? Okay, so that is where I will use joins. Okay, so let me first say select star from patients. Okay, and guys, there is something known as alias. Okay, which means now this, for this patients table, if I want to give it a nickname, okay, if I want to call it with some short name, okay, I will give it an alias. And how you give it an alias is just select star from patients P. Okay, so P becomes, now going forward in this query, P becomes my patients table. Okay, and you will understand why this aliasing is important, how it will make your queries readable and easy. Okay, so now select star from patients P, and I want to join allergies table. Okay, so I'll say join allergies. So first table join with second table. Okay, and join on what? So you always want to join on the common key. Okay, so here imagine this is like my, imagine this is a primary key and I don't have ID. Okay, this is a primary key and this becomes a foreign key in the allergies table. So we are going to talk about what primary keys and what foreign keys are. Okay, so basically they are the keys. So a table's unique identifier, okay, that is called its primary key, and that key, if it is present in some other table, okay, to create a relationship between those tables, then that key, now this patient ID in allergies table is a foreign key. Okay, now I'm going to join patients table. I'll name this allergies table alias as A. Why? Because when I say join, then I need to mention on which key. So on, now if I didn't alias the patients table, I would have had to write patients dot patient ID. Okay, but because I have alias this table, so I'm calling it its nickname just P dot patient ID is equal to A dot patient ID. Okay, and that's your join. Now if you run this query, see the results. Now it shows me patient ID 1001, John Doe. And if I scroll to the right, it has been joined on the allergies table. And now I know what allergy that patient has. See, penicillin, drug allergy. Now, when I join this table, see, it becomes very inconvenient for me to scroll to the right and go all the way to look at what allergy it has, so in real life scenario, what you're going to do is you would just need something like patient's name, so p dot first name. And whenever you join two tables, okay, there's a possibility that first name exists in both allergies table and patient's table. Okay, so in that case you always use the alias dot and then the column name. So okay, I'll say I want p dot first name, so patient's first name, p dot last name, comma, I want the uh, allergy event type, so I want to know what allergy that patient is suffering from. Okay, comma, a dot this column, because yeah, I want to see this information also, and if that allergy is active or not. So I'll do a dot allergy status text. Okay, and now if I run this query in a very neat and clean format, I'm going to see that John Doe has a drug allergy and he's allergic to penicillin, and that allergy is active, whereas Robert Johnson is allergic to penicillin and his allergy is resolved. Okay, so basically this is how the joins are used. It is used to join two tables together. Okay, because in a relational database, all the information is not stored in one table. So remember guys, I told you at the start of this video that I will later describe what a relational and a non-relational database is. And I think now is a good time that I explain you what is the major difference between the relational and a non-relational database. Okay. So what you're looking at right now, allergies table, diagnosis table, encounters table, family history, look at here. Okay. Patients table, all the different data is separated and it is stored into its respective table. Okay, and there are relationships between those tables, like the patient ID is a foreign key in allergies table. Now let's look at the diagnosis table. Select star from diagnosis. Okay, if you look at this table, here also you would see that patient ID is a foreign key here. So you can now, how I saw what allergy a patient has, similarly diagnosis is nothing but diseases. Now I can see what diseases patient, that patient has, like type 2 diabetes, essential hypertension, obesity, major depressive disorder, hypertension. Okay, so diagnosis has all the diseases that a patient is suffering from, and it is stored in its own respective table. Okay, and it has a relationship with the patient's table, and that is what a relational database is. Now I don't have an example to show you, but let me use chat GPT and show you how this data will be stored in a non-relational database. Okay, so for that, let me create a good prompt for chat GPT. Okay, so what I'm gonna do is, so guys, so this is an opportunity for you to learn how to give smart prompts to chat GPT. Okay, so what I'm gonna do is I'm gonna tell chat GPT that, hey, this is my table. uh okay, so create statement. So let's go to chat GPT. Okay, and I'm gonna tell chat GPT that, hey, I have below tables, patients and allergies. I want you to create a sample JSON file to show how this patients and allergies and diagnosis data will be stored in a non-relational database like MongoDB. I want you to output a JSON file with all these 3 data points in one single JSON file. Okay, so what I'm going to do now is because I don't want to waste so much of time in creating that data and everything, so we have ChatGPT. We are smartly going to use our ChatGPT. Okay, so I give, oops, okay, so unfortunately I have all this here. I need to get rid of this. Okay, all right, so I have my patients table. Oops, let's get rid of everything. So I have my patients table, send to create statement. So basically now if I give ChatGPT uh, this table schema, it knows what all columns my patients table has. So I'll also give it the allergies schema, send to SQL editor, create statement, create allergies. Okay, and now diagnosis. Okay, all right, now guys, what I want you to know is how the data for different sections or different topics like diagnosis, like allergies, like family history for that patient is stored in different tables. This is relational database. Okay, and now chat gpt is going to give us a sample JSON document. So look at this. Now if you see, so in databases like MongoDB, this data will be stored in files like this JSON files, and it will not be separate. Patient's record, patient records, allergies. Look at here, allergies. Okay, allergy key and everything. Diagnosis and all the diagnosis related information is stored in one single file. So that is called a non-relational NoSQL database, guys. Okay, I hope that is clear. So guys, I hope you all understood what an inner join is. Okay, once again, to reiterate, we have data stored in separate tables for separate topics. Because this is healthcare, so you will see patients table. Okay, and you have a patient ID. You will see allergies table, and you have patient ID here. Okay, the allergies key is its own primary key. Okay, now if you see diagnosis, it has its own primary key. Okay, and then that patient ID is a foreign key in the allergies table and is a foreign key in the diagnosis table. Okay, now I showed you how I joined two tables. Okay, now let's say I just don't want the patient's allergies, but I want to see what diseases he's suffering from. Okay, so I need to join diagnosis table also. So I'll just mention join here. Okay, give the table name. So that is diagnosis. And what are we going to do? We are going to alias it, give it a nickname D. Okay, and join on what? So which is my table P. So P dot patient underscore ID is equal to D dot patient underscore ID. Okay, now let's run this. Okay, before that, I only want some important columns from the diagnosis table. I don't want everything. So what I'm going to do is I'm going to take this encounter diagnosis text, okay, and add it to our select list. So here I just add it, I just put a comma and do D dot encounter diagnosis text. Okay, anything else that we want from here? Okay, when was that diagnosis documented? I mean, when was the first time that this patient suffered from that disease? So I'll just do D dot documentation date. Okay, now see, we have joined 3 tables together, and like this you can join multiple tables together. Okay, so that's the magic of joins. Now voila, here you go. So you got your patient's first name, patient's last name, his allergies, his diagnosis. And in this way, if you want, you can get n number of things by joining n number of tables together. Okay. Now in this, I can also filter. I can say that, hey, I only want record for John Doe. So where first, and remember, our patient's table's nickname is P. So P dot first underscore name. What are we going to do now? We are going to mix and match everything that we have learned. Okay, we're going to use those operators, those filter conditions and everything. So where P dot first name, and I'm going to use like operator here. Okay, where name like maybe John, and if I don't put any percent sign, guys, if you see, it will only search for John. Then it will not search, do a wildcard search. Okay, and P dot last underscore name like Doe. Okay, so if I run this query, the results will be filtered, and I'll only get results for John Doe. So let's see. Okay, so here's our patient John Doe with drug allergy, penicillin. It's still active, and he is suffering from type 2 diabetes mellitus without complication, and that was on 2024 Jan 10. Okay, now, so this is how you use the joins. Okay, and guys, remember this join, when I just say join, this means inner join. Okay, now that is about inner join. So what inner join does is it will return only the matching records. Now let me show you something. Do you see Jay Chaudhary anywhere here? I don't see. See, last name. Do you see Chaudhary anywhere? No. Why? Because if you see in patients, Jay Chaudhary's ID is 1013, 1014, 1015. Okay, this is the patient ID for these 3 different patients. Okay, now let's go to allergies table and see if their records exist there. It doesn't. Okay, I don't have 1012, 1013, 1014. So that's the reason. When now let's only join allergies table and let's only run this query. Okay, so see, wait, I'm gonna get error. Okay, let's run this entire query here. Let's get rid of this where condition. Okay, and let's run this query. So if you see, Jay Chaudhary is nowhere here in the results. And pay attention, guys, this is very important, because to understand inner join, you need to understand that the result set that you get is only for the matching records. Okay, so this patient 1013, 1014 and 1015, because they do not exist in this tables allergies and diagnosis, that's why they are, when I do inner join, they are not going to be part of the result that this query returns. Okay, now if you have understood this, now if you do now let's see what a left join is. Okay, left join is one of the outer joins. Okay, and what that join does is, suppose this is my patient table, this is my allergies table. Okay, and I have patient ID here, I have patient ID here. Only the matching records connect and they show up as a result. But what left join does is, even though this patient, okay, now left table means on your left hand side. Okay, so basically on your left means, so if you write this query like this, patients join allergies. Okay, which table is on the left? Patients. Okay, now when you do join diagnosis, okay, again diagnosis is the right table, patients is your left table. Okay, so what it does is, left join will return even the non-matching records, okay, from the left table, and they will return all the records that are matching from the right table, from the allergies table. So let me explain you this. Okay, let me do left. Okay, let's only focus on the allergies table so that it is simple for you guys to understand. So I'm going to delete this diagnosis table for now. Okay, and remove this diagnosis columns from my select list. Okay, now look at this, what happens. Now I'm doing join, just a simple inner join. Jay Chaudhary is not here. Let me do one thing. Let me also get the p dot patient ID here, patient underscore ID, just for better readability. So, okay. Now you see my 1012, 1013, 1014 are missing from this list. Why? Because they do not suffer from, they do not have any allergy, they do not have any diagnosis, or okay, forget about diagnosis, just talk about allergy. So they do not have any allergy, and that's, and inner join, when you use inner join, the non-matching records, I mean only those records will show in the result list which appear in both the tables or all the tables that you have performed an inner join on. Okay, now let's, instead of inner, we are only going to say here left join and see the magic what happens now. Okay, so now I see left, say left join allergies, so my left table is patients table. Now even though my 1012, 1013, 1014, they do not exist in allergies table, or for that matter in a human language to say that they do not have any allergies, but even they will show up in this list and their allergies will show null. Okay, and now you see where we can use this query in real life. So basically, I want to find all the patients where they do not have any allergies. How will I find it? I will just left join the patients table on the allergies table, and here I'll put a where condition saying that where a dot any of the columns in the allergies table, let's take it a primary key, a dot id is null. Okay, so guys, remember this is operator, okay, or is keyword, it is always used with null because we cannot do a dot id equals to null. Okay, this is wrong. It's always a dot id is null. Okay, and now look at the magic. Now what my intention was to find all the patients who do not have any allergies. What I did, I took patients table as my main table, which is on the left. I left joined it with allergies table. Okay, on what? On patient ID. Okay, and I said where a dot id is null, and when I run this, it only returns me this 4 patients, because these 4 patients, they do not have any allergy. Okay, so guys, try and imagine. Okay, basically it is very powerful. Okay, all these joins, maybe inner join, left join, right join, they're very powerful, guys. Okay, when used in a right way, you can write a lot of logic which makes sense. Okay, so a very typical example that we see on YouTube is that, hey, give me all the customers who do not have any order in this month. Okay, so it's the same query. Customer table is going to be your left table. Orders table is going to be your write table. Customer ID is going to be the joining key. Okay. And where you're going to say where order.id is null and date, or you're going to put a condition where order date is this month of July. Okay. So it is going to return you all the customers who haven't placed any orders in month of July. So I'm just trying to make sure that you get this concept clearly. Okay. And I hope you're following me. Okay. If not, please feel free to leave a comment and I'll make sure to reply. Okay. All right, guys. So now we are clear with left join and inner join. In the same way, we can use right join. But if you have understood the left join correctly, right join is just opposite of it. It is just that the table which is on the right hand side, all the records will return from that table and only the matching records from the left hand side will return. And believe me guys, in real world, never used right join. I have never used right join. If I wanted to find something like that, I would just simply take the table on the right and put it on the left and use the left join. Okay. So I hope the joins funda is clear. So let's move ahead. Now we will jump into subqueries. Okay. So let's see what subqueries are. Okay. It's very interesting and it's pretty simple. So suppose I have this patient, select star from patients. Okay. I have this patient table. Now let's look at the allergies table. So I want to find all the patients which are allergic to penicillin. Okay. Here. Okay. So how will I write a subquery for this? So pay attention. So let me get rid of this joins. Okay. Select star. I want to find all the patients from the patients table who has allergy to penicillin. I can do that using joins. Okay. I can just do this allergy where a dot id is null. No. So I'll do where a dot allergic to text, and instead of equal to I can do like, and just for safety I can put this percentage and penicillin. Okay. And if I do this, I should get that information. See. Okay. But what's the other way of getting it? You can do a subquery. You can do select star or any columns that you want, specific columns. But for now, I'm just going to take all the columns. So select star from patients. Okay. And name it as P, where P dot patient underscore ID in. Okay. Because there can be multiple patients. So where P dot patient ID in, and now I'm going to select all those patient IDs from the allergies table, okay, which are allergic to penicillin. So how I'm going to write this query is select patient underscore ID from allergies, okay, where allergic to text, like penicillin. Okay. Now if I do this, so what happens is this query returns this result. Okay, patient ID, and that patient ID is then passed to this query. So basically this query is nothing but it is okay. First let's see the result, then I'll explain you. Okay. So if I run this, what I get is again those two patients which I saw above, Doe John and Johnson Robert, and they are allergic to penicillin. So there are multiple ways of getting the same results. It depends on what your use case is, but yeah. So look at here, this is the same result: John Doe, Robert Johnson, allergic to penicillin. Okay. Now let me explain you how subquery works. Okay. So in subquery, this query will be executed first. Okay, this query will be executed first, and it will return this 1001. So it is same as writing this query. It is same as writing it is same as writing this. See, you run this or you run this, will give you the same results. So that is how subqueries are used. Okay, pretty simple. So basically, the outer query will will contain a where condition. Okay, and in where condition, whatever column you have mentioned, that column will be in your select condition for the subquery. Remember that, guys. Okay, and always think like this. Okay, so this query first executes, returns this IDs, and these IDs are passed to then this outer query. Okay, so that's subquery. Now just consider this query. Okay, so I have patients and their allergies here, and I have something called as allergy status code. Okay, and here some of the values are A and some are active. I want to standardize this. Okay, so what I can do is I can write a case statement here and say case when the value of this column allergy status code equals A, then active. Okay, I can write many conditions here. So this is like if else. Okay, but it's just instead of if else it is when then. Okay, so you start with case, you have to write, this shows that there's a beginning of case statement. Okay, and then you write when, and then whatever condition you want to check, and then whatever value you want to put with that condition. So in here, so when a dot allergy status code is A, then put it as active, and when A dot allergy status code, let's put something else. Okay, so let me first modify this allergies table, and let me put a status code something like resolved. Let me put a R here for resolved. Okay, just for this video purpose. Okay, now I have updated that table. Okay, then I say where A dot allergy status code is equal to R, then resolved. Okay, and then you end this case statement, end, and now this case statement has created a new column, so you need to name that column something. So you do as end as allergy status. So this will become the column name. Okay, allergy status. Now if you run this query, let's see what happens. Okay, so basically what has happened is this case statement, as I said, as I told you, it is just if else block. Okay, so I said that when this a dot allergy status code is equal to A, then put the value as active, and when a dot allergy status code is R, then put the value as resolved. Okay, so and see, so it did that, and it and end as allergy status. So it created a new column called as allergy status, and it put all these values. It checked for each and every record what the allergy status code is, and it put that value in front of it. Okay, whichever we told it. Now just pay attention here. For active, inactive, it has put allergy status as null. Okay, so if you want to handle that, you can do that as well. How we can do it is add another condition, another where condition, or if you don't want when condition, then we can also do else, just default value for everything else. So that will be not unknown. Okay, I don't know what it is. So now if we run this query, Let's see the results. Okay, now for A I have active, for R I have resolved. Okay, but for those values that I haven't mentioned in my case statement and I put it in else block, as unknown, they are now coming as unknown. Okay, so that's the use of case statement, guys. Okay, it is nothing but a simple if else block. You can play around with it as much as you want. If you want to see a simple example here, so I can say, let's play around. Okay, so I will say, instead of a.allergy status code in the case statement, I'll say that allergic to text. Okay, let's take this. If allergic to text is penicillin, okay, for this penicillin, let me copy this. Then I want to code pen. Let's say pen. When allergy status code, when allergy to text is equal to peanuts, okay, then I want to say peen, okay, or nuts. Let's say just nuts. Okay, else unknown. So basically, now what result do you expect? Okay, and end as, let's not do allergy status. Let's give it some sensible name, because now we are talking about the stuff that they are allergic to. So end as allergic to. Okay, now if I run this, let's see what happens. See, for penicillin it says allergic to pen. For peanuts it says allergic to nuts. For else we can give no allergy, all good. Okay, so that is what case statements is used for. It is again nothing but a simple if else condition. Okay, cool. All right, what else? So we're done with case. Let me look at the syllabus here. Going forward, we have some interesting things like Windows functions. Windows functions is very interesting, very powerful to use. Before that, let's look at some of the functions like coalesce. So it is spelled as COALESCE, coalesce. Okay. Let's see what's the use of coalesce. Okay, so definition of coalesce is that it will return the first non-null value. Okay, however, doesn't make sense. Definitions, I hate definitions. Let's see what exactly it does. Okay, so we are going to see a practical example of what coalesce is going to do. So example here in telephone values, if you see, I have a lot of values here where the telephone number is not present. This is null. So let me put some telephone number here, some fake telephone number in the telephone value 2. Okay, so telephone value 1 has nothing, but telephone value 2, let's put something there. And again, for those here, this is null, so let's put something here. Okay, and something here. So I just want to see, I just want to show you guys what coalesce does. Okay, and how to use it in real life. Okay, not just definition. Okay, so now here in the patients table, I want first name, last name, and the phone numbers, okay, of the patients. So what I do is select star, no, not star, select, let's copy paste, first name, feeling a little lazy, first name, last name, and let's say phone number. Okay, so our phone number column is telephone value 1. Okay, so I'll select this, but doesn't sound like a very good column name. So again, I'm going to alias it, and instead of telephone value 1, I will say as telephone number. Okay, this is better. Okay, from patients table. So what this query will return is, okay, it will return first name, last name, and the telephone number of the patients. However, if you see, some of the telephone numbers here have no value, they are null. Okay, now in some scenarios, in some cases, suppose I have not stored telephone numbers for few of the patients in their telephone value 1, but I've stored it in telephone value 2. Now in this query, what I want is, hey, return it if it is in telephone value 1, else return it from telephone value 2. So in this case, what I'm going to do is, I'm going to do like this, comma, this, and I'm going to wrap it around coalesce function. So I'll take this function and I'll say coalesce of telephone value 1 and telephone value 2. So what coalesce will do is, record by record, okay, it first checks telephone value 1 has a value, return that as telephone number. Second record has a value, return that as a telephone number. Third record, oh, it is null. Let's look into telephone value 2. And if it has, then return telephone value 2. So in this case, what happens is, now look at this. Now if I run this query, it will return the first non-null record, which simply means, that's the definition, but which simply means that inside the coalesce function, as an argument, whatever number of columns you specify, it will return the value of that inside that column which has a non-null value. Okay, so now see, all the patients here has a telephone number. Why? Because I coalesced it. Okay, now what will happen, suppose in some cases like this, Jay Chaudhary, let me go ahead and remove his telephone number. Okay, let me remove the telephone type 2 value from here. Okay, and let me save it. Now if I run this query, it will not get a non-null value and it is going to return null. See. So here I can also do something like, I can put a third value, 2 columns, and one hard-coded value saying that number not found. Number not found. Okay, so basically now if it doesn't find a proper value, like a non-null value in telephone value 1, 2, then it will return number not found. So let's try this. Oops, got it. This is because, now can somebody think and tell me why it is still not returning number not found? It's very interesting, because remember guys, what is the definition? Coalesce will return the first not null value. Okay, however, if you see now this record, this patient telephone value 2, it is not null, it is blank. See, this is null, this is null, this is null, this is blank. So I'll need to go ahead and set it to null. So this was blank. Now what we are going to do is, we are going to set this to null. How you do it is just right click and set field to null. Okay, and now I'm going to save it. Now if I run this, now because telephone value 1 is also null, 2 is also null, before it was blank guys, remember, and blank and null is not the same. Okay, So blank is also a value. Okay. On a memory level, if if you store a blank, it occupies a space. It has a specific Unicode to you know to determine that this is blank. So remember, blank is not same as null. So now in this case, if I run this query, see, I get number not found. Okay. So just remember, guys, coalesce is basically a function where as an input you can provide many columns to it, comma separated, and it will look into all those columns in order and return the value of that column which is not null. Okay, so hope this is clear. Now let's move to a row number now. Okay, it's a Windows function and it's very important. Okay, little complicated to understand, but if you understand it well, then you all sorted. It's pretty good. Okay, so to implement the row number, let's look at our patients table. Okay, now what I've done is, look at this patient ID 1003 Johnson Robert. I've created one more record for that, which is 1003 Johnson Robert, and here also we have 1003 Johnson Robert. Okay, uh, and here we have three duplicate patients which has the same who has same patient ID 1013 1013 1013 Jay Chaudhary. Okay, now uh, all these patients are created at a different time. Okay, uh, so look at this. One record is created at 1559, another is created at 1701, and then next is created at 1731. Okay, now suppose I want to delete duplicate records. Okay, suppose these are three records. Okay, and I want to keep the latest one. So I will basically keep this one. Okay, but I can't do this manually. Okay, so for that I can't, like, suppose there are millions of records like this, and I can't keep on checking by time, manually, like this, which record is created when. And uh, suppose if I want to assign a row number to these records, okay, as per the time they were created, so this will be row number 1. Okay, because this is created first. This will be row number 2 because this is created after that, and this will be row number 3. Okay, because this is created after that. And for other records, because they don't have duplicate, so this will just have one row number 1. This will have row number 1, but Johnson Robert is created two times. Once Johnson Robert is created, let's see when it was created, on June 22nd, 10:13 a.m. Okay, and when was another record of Johnson Robert created? 1011, and this was created June 22nd, 10:13 again. So what is June 10:13? Okay, let me change that time a little bit. Let me do it June 25th. Okay, just for this demo purpose. So now technically what will happen is, if I want to assign a row number to duplicate records, okay, I want to find duplicate records and I want to assign a row number to them. How will I do it? So that is when your Windows functions will come handy. Okay, very useful. So let's say this. So I will select ID, comma, patient underscore ID. Okay, I will select the first name of the patient. I will select the last name, and last column I want is when was this patient created. So I will select created at time. Okay, now what I can do is, for Windows function, I will just say, because it's a function, I will say a row underscore number. Okay, and then this function brackets, and then over, okay, open bracket, close bracket. Now here what I would mention is, first I will write it. First I'll write the syntax, I'll run the query, and then I'll explain you how it works internally. Okay. So I will say over, and I'll have to say partition by. So partition by, and I want to partition this entire table by patient ID. Okay. So I will partition by patient ID, and I will order by created date. Okay. So created at. As, and I will name this as row number column. Okay. And I will run this query. So let's see what happens. Okay. Now if you see John Doe, row number 1. Now this Robert Johnson, see how it assigned row number 1 to this, because this was created before and then this was created later. Okay. Now look at Jay Chaudhary. Okay. This was created before, so it assigned it number 1. Same rank also works the same way. So I can even say rank here actually. Okay. And see. So if you see Jay Chaudhary, now this 3 records, they have got a row number. Now I can even do this. Select star from this table. Okay. Now we have this table as RN where RN dot row number greater than 1. Okay. So now it has returned all duplicate records to me. Okay. Now let me explain you. First, let me get rid of this. Let's only and only focus on our inner query first. And okay. So what is this doing? When I use rank or row number function, does the same thing. So when you say row number and then you say over, partition by, this is important, pay attention here. So what I'm doing is I'm partitioning the entire table by the patient ID. Okay. And I'm ordering it by created date. Okay. So what it will do is it will go to this first record, patient ID 1001, because I'm partitioning by patient ID. So do we have another 1001? No, we don't have. So fine, row number 1 assigned. So created at, only one date created at. So row number just 1. Do we have 1002? No, we don't have. So row number 1, and again there's only one created date because we are partitioning by patient ID. So partitioning is very important. So whenever you want to assign a row number or rank to any data set, you partition it on that specific columns or group of those columns where the data is the same. Okay. So example now, Robert Johnson 1003. It will go to patients table. It will see 1003. Okay, I have Johnson Robert, and 1003. Okay, here I have Johnson Robert, and then it will see it has another record of Johnson Robert. It will take both the records. Now what we have asked it to do is order by created at. Okay, so from these 2 records, Johnson Robert, let's go back here. Okay, so from these 2 records, it will order it by created date, and then because it has got 2 records, so for that column mentioned in the order by clause, it will assign 1 to the lowest value of created at, and then the value higher than that it will assign 2. Okay. Now, and the same way for Jay Chaudhary. So it looks at 1013 partition by patient ID 1013. Okay, I've got 3 records. Now which record I assign row number 1, which record I assign row number 2, which record I assign row number 3 depends on the created at. So first earliest record, the oldest record that was created gets number 1. After that number 2, after that number 3. Okay. Now look at the magic. What I can do here is I can simply do order by created at DESC. Okay. Descending. And now what it will do is it will assign 3 to this, 2 to this and 1 to this. So latest record, because now it will order those records in descending order. So now the latest record, the newest record that is created will get number 1. And the record that created just before that will get number 2. And the oldest one will get the number 3. So let's look at this. So just pay attention. Now July 31st, July 20th, 5/31/29 is row number 3. Now if I just ordered by created at, and instead of ascending I'm just doing descending, and now everything changes. Now if you see this record, which is just latest record, now it gets row number 1. Okay, and the other records will get 2 and 3. Now why is this used? Suppose my boss tells me, Jayesh, I want to delete all the duplicate records from the patient's table. I don't want duplicate records from the patient's table. It's not as simple as that, but just a hypothetical situation. Okay, so basically he says that no, not hypothetical, actually this is real, because the patient IDs are duplicate here. Okay, so he says that I want to keep the latest record and I want to delete all the old records. I want to only keep the latest record. How will you do it? This is the way you do it. Okay, so what I do is I say select, I can just select ID from here. Okay, select ID from this table. So now my inner query, this, I just make it a table here. Select ID from this table. So what it does is from this entire table now, okay, this is the inner query. So this, the result of this query is this table. Okay, now in the outer query I am saying select ID from this table. Okay, so this table is created in the memory. Now I'm saying just select ID from this table. I have to give some alias to this table. So I'll give it alias as just for now RN, which is for row number. Okay, and I say select ID from RN. Okay, where RN dot row number, this column here. Okay, row number is greater than 1. Now this returns all the duplicate records. Okay, so see 3, 25, 24. If you want to confirm, and then what I will do is delete from patients, where now we use our subquery. See guys, how we are joining each and everything that we have learned in this course. Okay, so basically remember guys, whenever you get a problem, start, break it into pieces and solve one piece at a time. So first what we solved is how to get the duplicate patients. Okay, so I have this patient ID. I'll assign a row number to each row, and I will partition the table by patient ID, order it by created at as descending, and assign it a row number. So now my duplicate records, the newest record has 1, older has 2, and the oldest has 3. Okay, so now, and then what I do is I just select the ID from that table. Okay, so I get this result. Now it is simple for me. I just want to delete this records from patients table where ID in, and this is my subquery. If I run this query, if I run this query, this duplicate records will get deleted. Let me show you. So 3, 25, 24. Okay, 3, 25, 24. Let's see if they're really duplicate. 3, Johnson Robert. Is it duplicate? Yes. Why? And is it the right record to be deleted? Yes, it is, because this Johnson Robert was created before our other Johnson Robert, which was created on June 25th. This one. This was created on June 25th. This was created on June 22nd. So do I need to delete this 3? Yes. Which else do I need to delete? 25. What is 25? 25 is Jay Chaudhary. Okay, when was this created? 25, and it is asking me to delete 24. So 25 and 24, these ones. So 26 remains. So latest one remains. Okay, so this is perfect. So let me, okay, so I'm just going to temporarily delete it. There is a way to temporarily delete those records. So I'm going to start a transaction. So until I commit this transaction, okay, this transaction is like a scope. So once I start the transaction, run my query, at the end, if I commit the transaction, only then this will take effect. Else, if I roll it back, it will get rolled back. Okay, so I'm starting the transaction. Okay, now I'm deleting the records. Okay, if you see, our records got deleted. Oops, let me clear this. Okay, so see, it says delete from patients, three rows affected. Okay, now if I go back and look at the patients table again, do we have our records? No. See, our uh, 24, 25 got deleted from here. See, only one Jay Chaudhary. Johnson Robert, only one, the latest one. The other one from here got deleted. Okay. So this is how you use row number, rank. Syntax is the same. Okay. I'm not going to waste time on teaching about rank and dense rank. Okay. It's a very simple concept, because I think once you understand the usage of this Windows function, it is very powerful. Okay. And that is what I'm focusing on. I want you guys to actually understand the usage of it, not just theoretically. I've seen other YouTube videos, and I've seen that the examples there are so theoretical that it's very difficult for people to really relate how these functions work. But I hope that uh, you know I've been able to do a good job, and you guys understand how this row number is used. So before I forget, let me just roll back the transaction. Now, if once I roll back the transaction, what's going to happen is these patients are not actually, they're temporarily deleted. Okay, they will only get permanently deleted once I do commit. But instead of commit, I'm doing rollback. So once I do the rollback, now you'll see those patients again in this table. See, 25, 24 is here. So I was just testing if that query that we have written is correct. So yeah, so that's how you use row number, rank, dense rank. And I hope that is clear. So what's next in our agenda? Let me see. All right, guys. So now let's look at a very important topic, which is called common table expressions, or they also known as CTEs. Okay, CTEs are very important, guys. They can make your complicated queries look very simple. Okay, and so let's jump into it and let's look at it, what I mean. Okay, so let's look at this table. Suppose I want, now here in this query I get patients and their allergies. Okay, now what if I want to know patient and the count of allergies that patient has? So what I'll have to do is, we have learned about count, so I'll add a count of star here. Okay, and I'll have to group it by patient ID, first name, and last name, like this. Okay, so once I group, and I'll also have to group by allergic to text. Okay, so remember, all the columns that are not in a function, in an aggregated function, should be a part of group by. Now if I run this, what will happen is, it will give me all the information that I wanted: patient ID, first name, last name, what is his allergy, and the number of allergies he has. Okay, so okay, we actually want the total number of allergies, so I cannot include this allergic to text in the select clause, because like example, this Robert Thompson, he has different allergies: peanuts, penicillin, shellfish, pollen, aspirin. Like this Susan Thomas has different allergies like amoxicillin, animal dander. So when I group by, then because this is not this is unique strings, it doesn't group it, and it doesn't give a total count. Okay, so I'll remove this allergic to text, and what I instead want is the total number of allergies that they have. Not interested in what allergies, allergic to what, but just in simple, which patient has how many number of allergies. So now if I run this query, boom, so it says that John Doe has one allergy. Okay, I can also rename this column as count of star as count of allergies. Okay, so this is how you rename the columns for more readability. So now you see Linda Martinez has two allergies. Check here. Susan Thomas has two allergies. Robert Johnson has five allergies. Okay, now here is where your CTE can be useful. Okay, so instead of writing a join query like this, what I can do is I can write this query like the syntax of CTE is with, and you can name your CTE. So when you say with, you can say CTE1, or you can just give some sensible name that with allergies count. Okay, that is the name of my CTE now as keyword, and then open bracket, close bracket, and you write your logic in this bracket. So what I'm going to do is I'm simply going to select a dot patient ID, comma, count of star, okay, from allergies table, allergies A, okay, from allergies A, and I'll just do simply group by a dot patient ID. Okay, now see guys, if I just run this query, what it's going to give me is, first, if you want to see, look at the allergies table. Okay, so what it will do is it will select the patient ID, it will select the allergic to text here. Okay, now it will group by that patient ID, and it will give me a count of each patient ID that is there in this table. So example, for this 1006, it will say count 2. For 1011, it will say count 1, 2, 3, 4, 5. So if you run this query, see what's the result. And now that query is your common table expression. So that's like you have just separated the allergies logic, the count of getting the allergies from this join, okay, and you have placed it in a CTE. So you do with allergies count as this. Okay, so this becomes your allergies count common table expression. So consider it like creating a temporary table in the memory. Okay, and now simply what I can do is, now I can use this CTE. So I'll do select, and I'll use the same columns that I used here. So select p dot patient ID, p dot first name, p dot last name. Okay, and now I want the count of this allergies count CT. So I'll just take this, I'll say allergies count dot, okay, I can name this count of star as anything, like count of allergies, and I can use it here in my query. Okay, so patient ID, first name, last name, count of allergies from our patients table P and join it on this CTE allergies count. I would say I can say A. Okay, on P dot patient underscore ID equals A dot patient underscore ID. So what this is going to do is just look at the flow of this query. Okay, first if I run this query entirely, it is going to give me the same results as this upper query. Okay, however, for readability purpose, I've made it little easier. What I've done is, okay, first system will run this CTE and create a temporary table in the memory. Okay, that table is going to have these columns: patient ID and count of allergies. So take it as, just imagine it that is, this is our new table. Okay, and now we have a patient IDs and their count of their allergies in this temporary table, which is our common table expression. Now I simply just join the patient table, join this CTE, and get the information that I want. Okay. Now this is just a one small example, guys. Now just imagine that instead of only the count of allergies, I also want the count of diagnosis. Okay. So what can I do? Okay, now this query has started becoming complicated. So I'll have to join the diagnosis table here. So I'll say join diagnosis D on P dot patient underscore ID equals D dot patient underscore ID. Okay, and so see, now this query has started becoming difficult for me because I can get count of allergies, but how will I get count of diagnosis now? It is possible to do this like this, but it's becoming now more difficult because one patient has many allergies, one patient can have many diagnoses. So now in this case, it has started becoming difficult. So what can I do? Okay. So here is where our CT comes, comes into play. And this is how CT makes life easy. So now I can have multiple CTs. I can say with allergies count as this, and then I can just simply say another CT now with diagnosis count. Okay. No need to use with keyword for the second CT, and the first CT has to be separated from the second by with this comma. So now diagnosis count as, and now your second CT, open bracket, close bracket. Now I do the same thing here, okay, but with the diagnosis table. So what I'll do is just copy this, I'll paste it here, and I'll say select A dot patient ID count of star as count of diagnosis from diagnosis table. Group by A dot patient ID, D dot patient ID. Okay. Now see what this query returns, guys. Okay. So this query returns the number of diagnoses that each patient has. So see this patient 1011 has 5 diagnoses. So he's suffering from 5 different diseases. If you want to check that, you can just query our diagnosis table and see patient 101, 1002, everybody has just one, but 1011 has, yes, 5 diagnoses. He looks like a very, very sick patient. So yeah, so now what I've got is in this CT with allergies count, I have got the count of my patients and their allergies count, and in diagnosis I've got the list of patients and their diagnosis count. Now what I simply do is I just join my other CT, which is join diagnosis, and I can give it a nickname or alias as D. Okay, on again p dot patient id. So I'm just going to do some copy paste work. Oops, it has to be here. Join diagnosis D on p dot patient id equals d dot patient id, and here now I will just use the d dot count of diagnosis. Okay, and here we go. So whenever you want to execute the CTE, okay, you select all the CTEs and the select query and execute it together. Okay, seems like we got some error. There is some syntax issue, it seems. Unknown column d dot count of diagnosis and field list. Okay, let's see what it means. Unknown column d dot count of diagnosis. Oh, I need to join it with my this CT, not with my table. So okay, so my main table is patient. I joined it with this allergies count where I have the patient ID and the count of allergies. And here in another CT, I have diagnosis count. So I have patient IDs and their count of their diagnosis. And then in my main query where I fetch the data, I join my patients table with the allergies count, with the diagnosis count CTs, and get the data. So let's see what happens. You see? So see guys, this is how you use common table expression. So when the logic is very complicated and you know you have to join multiple tables and do a lot of functions and group bys in your one query, that is when you use common table expressions. Okay, split your problem into small pieces, solve one problem at a time. Like first I created the allergies common table expression, got the count of allergies in that temporary table, imagine it like a temporary table. Then I created a diagnosis count common table expression, and I got all the count of diagnosis for those patients in that common table expression. Then I used the patient table, joined the allergies CTE, joined the diagnosis CTE, and my work becomes so easy. This query is also so readable. Anybody else who is going to read your query, they're immediately going to understand what you're doing here. So guys, that is how you use CTEs, and I hope that is clear. If you have any questions, please ask it in comment section. I'll make sure to reply. Let's move to our last topic for this lecture. So our last topic is indexes. So indexes is it's very important, okay, because indexes actually optimize your query performance and your database performance. So basically there are some basic indexes like clustered indexes and non-clustered indexes. So first let's understand what indexes are. Okay, so indexes are the way your data is stored on on the disk, or how your data is arranged. Okay, so example, when you create a primary key on a table, so for our example we'll take this select patients table. Okay, so when I create a primary key, so this ID is my primary key. Okay, this ID is my primary key. Now what happens is this data is physically arranged in order of this primary key. So ID1 will be stored, then ID2 will be stored below that, ID3 will be stored below that, ID4 will be stored below that. Okay, now that is what a clustered index is. Okay, uh, so now if you see this table patients internally on the disk or in the database pages, the data in this table is arranged as per this ID column. Okay, now just imagine that I have billion records in this table, okay, or 10 million records in this table. Now, if I say something like, uh, let's say, select star from patients where last name like Doe. Okay. Now, guys, try to understand what this query is doing. Okay. So, if I don't have indexes, okay, what this query is going to do is record by record, it is going to read the entire table. So, it is going to read millions, billions, 10 million records to actually get or fetch the patients where the last name is Doe. Why? Because this patient has 10 million records, and it only has clustered index because I have created a primary key. So a person with Doe can be stored anywhere. Person with last name Doe can be on the first page, and he can be on the last page as well, because I am asking it to return all the records which has last name as Doe. Okay. So this is called something as table scan, which is very bad, or full scan. And this is very very bad, guys, because if you guys understand data structure, just imagine if there is an array of size 10 million, okay, and it stores names, okay, and it stores names, and you in that array of size 10 million, you want to find each and every index where the name stored is Doe. Just imagine, you will have to traverse the entire array, okay, entire uh, 10 million indexes, and find out where name Doe is, or return all the indexes where the data Doe is stored. Okay. So now in this case, what we do is we create a clustered index. We create a non-clustered index, okay, on name column. Okay. So basically, what this non-clustered index will do is it will arrange all, it will arrange, I'm looking for the last name. So it will take all the last name values, okay, and it will arrange it alphabetically. Now what happens? So where our time complexity before was that of n, big O of n. So if you guys understand data structures, and if you know the time complexity, if it has to traverse each and every uh, index of the array, the entire array, the time complexity becomes n, okay, big O of n. Now there are better ways, right? If you have a sorted array, then you can use different traversing techniques to get a time complexity of log n. So in this case, suppose if the last names are arranged alphabetically, okay, so my first database page maybe has uh, all the last names starting with A and B. Second page has C and D. Third has E and So what does the engine now has to do? Now it doesn't have to traverse the entire table. It doesn't have to scan the entire table. All it has to do is go to the page header, find, okay, uh, okay, only A and B are stored here, okay, only C and D are stored here, no, I don't need to scan it. Then it goes to that page where last names with alphabet D is stored. Great. Now it only has to scan you out of 10 million records. Now it only has to scan maybe few hundred records. Okay. So imagine how fast it's going to be. Scanning 10 million records and finding that last name Doe and scanning only 100 records. So it is going to be 100x faster, So guys, make sure that you're aware about this non-clustered indexes. Okay, and a very simple way to determine columns that require this non-clustered index is the columns that you use in your where clause a lot. Okay, so if your application is querying the patient table, so you have a front end application where you are searching for patients. What will you search with? You will search with first name, you will search with last name, or maybe you will search with their some ID that you have assigned to them, or their telephone number, or their email address. Boom, you got all the columns that you need a non-clustered index on, or an index on, and those are these columns: first name, last name, email address, phone number, where, because if you're searching by that patient, if you're typing in the email address of the patient in the backend, the query that is running is select, this columns from patients where email address like da 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 da. So what will happen is, okay, it wants this email address. If there is no index on that column email address, it is going to do full scan, and boom, your system is going to go for toss. But if it has a cluster, if it has an index on that column, it exactly knows where to look for that data, and it only scans few pages and not the entire table, guys. So remember this, it is very important. Okay. All right, and with this, we are going to end our today's session. I hope you all enjoy learning SQL, and I will see you in my future videos, which I'm going to make about ETL pipelines. It's going to be more advanced and interesting topics. I'm going to start with the Python series soon, and after Python, we are going to learn about pandas, data frame, and uh, PySpark and Spark SQL, because it is very powerful tool to do some uh, data processing for very huge data sets. So stay tuned for that, and I would like to hear from you. So if you have any feedback, you can put it in comments, or if you have any questions, you can reach out to me on my email address, which is, let me just type it here so you all have it: jchaudhari06@gmail.com. And you can also search me on LinkedIn. Here on the screen is my LinkedIn profile page. So please go ahead and send me a connection request on LinkedIn, and I request you to, if you find this videos useful, then please send it to your friends, and share it with them, uh, and please do like and subscribe to my channel if you like the content that I'm creating, and if you think it's going to add value. So thank you so much, guys. Have a good day. Bye.